love you dearly, but how you came into math class and nothing out is a little beyond me.
I appreciate that.
Okay. So you got it, you cut it, you folded it. I don't care, but I'm going to talk math now. Okay. So now you have out your notes from yesterday. We got distracted at the end of class, and surprisingly, so we didn't quite finish up what we needed to with describing scatter plots. So we're a little behind today. Yeah, we were a little scatterbrained. So I have out my notes from yesterday. We're going to come to those. I guess we could go ahead and look at one of the flaps in here. The flap that says how to enter data into lists and graph a scatter plot. You learned how to do before today, but in case you forget, the exact steps are listed in here. So it tells you to go to edit, to type it, to press the stat button, go to edit, type it in your list, go to stat plot, turn your list on, turn it into a scatter plot, pay attention to what you pick for X list and Y list. And of course it even reminds you to do zoom stat. So I really like that, and if you're one who's having issues with calculator buttons, like you just keep forgetting because there's so many different things, it's a cute little handout to remind you what to do. Okay, are there any questions about this flap? Because I'm going to let this flap go. Okay, cool. So yesterday, before we died, we were talking about describing a scatter plot, and we were discussing how to change this acronym. It's DOFS. I don't care if you call it DOOFS or DOFS or DOFS. I don't really care. Okay, the D is for direction, the O is for outliers, the F is for form, the S is for strength. So we're going to talk about that today. And I don't know if you still have graphed our stat plot from yesterday. I pray you do. To be honest, I wish I was consistent with which calculator I use every day. Does yours look something like this?
Yes.
Okay, perfect. Then I did pick a good one. Awesome. Okay, so when we're describing a scatter plot, like the one we graphed yesterday, the first thing we want to do is direction. We're going to talk about the direction. Meaning, what's the general trend of the pattern? So is there a positive association or a negative association? So does it look like a positive linear line going uphill, or does it look like a negative line going downhill? It does look positive. So for our example from yesterday, we see a positive association. What's the word we're not going to use in this section?
Causes.
Yeah, so we're not going to say that the points causes are number of wins, but we're going to say there's a positive association between points scored and number of wins. Okay, and then, so D was for direction. So just positive association, negative association. And sometimes you can't tell. Sometimes it might even be a non-linear association. Okay, so if when you make a scatter plot, if it looks a freaking hot mess and doesn't look like you could maybe fit a line to the data, there's not a good association, so we're stuck. Now, one would pray that that's not what they're giving you on a free response question, but I can see how in a multiple choice question they might do something like that. Bless you. Okay, so direction is D. The O is for outliers. We had a formula for outliers in chapter 1. What was our formula?
Q3 plus 1.5 times IQR.
Or
Q1 minus 1.5 QR.
And that's perfect for things when we're doing the one variable. But right now we have two variables, so there's not really a set formula that we're going to discuss at the moment. It's just kind of like how far away from you from my line. If you're super far away, we're going to deem you an outlier. It's going to be okay in this section if you deem something an outlier without backing it up for now. Do what, dear? I would reference the specific point. So I don't see anything that looks ridiculous in our data. Here, let me turn my light on. That might help. So I don't see anything that looks ridiculous. So if we fit a line through it, I don't see anything that looks super far away. But if we had a point down here, then we'd be like, that point is an outlier. So I sure did. It's mine. I can do what I want to name. So we would say that point is an outlier, and we should probably reference it as to what the actual point is. So that would be my suggestion. It's my calculator. Okay, so the outliers is just seriously using your blind eye. And then the F is for form. So back to the form is, does it actually follow a linear pattern? And then I guess this is how they're fitting in outliers, but I like to have outliers with a whole separate letter. So linear pattern, curve pattern. You know what a parabola looks like?
Parabola.
Yeah, so, or some other type of parent function. It could be that. We pray it's not, but back to that would just be nonlinear. We're wanting linear, and if it's not, we're just going to call it nonlinear. So seriously, for form, I either use the word linear or I use the phrase nonlinear. Form, I don't go any further than that. And heck, let's be honest, if in your direction you said nonlinear association, you've technically done D and F at the same time. But as I said before, if this is a true frappy question, never would they make you make a scatter plot and it not have a linear association of some sort. Okay, and then strength is how closely do the points fall to an imaginary line or a curve. Meaning, if we were to fit a line, you're going to be mad at me again, if we were to fit a line through this data, these points are pretty close. Like, this one's kind of far away, this one's kind of far away, but otherwise our points are pretty close to that graph. But we could have one where it's super spaced out, like, and we claim this line fits the data. Well, clearly it's nowhere near some of those. So just how good does it fit? And you're like, how do I measure that? And we're going to get into things to do today. Okay, so using the previous scatter plot, describe what the scatter plot reveals about the relationship between points per games and wins. Make sure to comment on whether the scatter plot shows a positive association, negative association, or no association. Okay, so if you see a question that asks you to describe the relationship between, and then they give you two variables, you're probably supposed to use this acronym. So we need to use the D, the O, the F, and the S, and some of us have been doing it out loud as we go, but let's go ahead and write it down for the rest of us who have not been. So for example, yesterday, the D was direction. Was there a positive association or a negative association? There was a positive association, but we need to be specific. We need to reference our context. So positive association between what and what?
Between points per game and games won.
That would work. I was just using the PPG because that's the way they phrased it yesterday, points per game. But no, as long as you're saying points and games won, you're good. So we've done the D. Now for the O, are there any outliers with our data that we notice with the blind eye?
No.
So I would say no outliers observed. And then I'm not going to write it, but if we were being obnoxious, which is not a bad thing, it's not bad to be a smarty pants. We could go into why there are no outliers. So why does this data, it could have an outlier, but why does it not have an outlier? In real life, using the actual context, why are there no outliers?
It's the game even.
So only the team with the most points wins the game. You know, I don't put wins in quotation mark. But there's something else we could say as to why there are no outliers. What do we not allow?
Negative points.
No negative points. Again, we're referencing the specific sport of football because it was an SEC football example. There's more to it than that, though. Thinking about rules with football, why there are no outliers. I can think of another reason as to why there are no outliers with this specific set of data.
It's not a maximum number of points. Yeah.
Isn't there a rule like if you score a certain number of points over somebody who's in the game?
No, but there is a
Football stuff.
there's a politeness score is what I'm going to call it. It's like if you're kicking someone's butt, it's where you only kick someone's butt so much. Like if you're winning 42-0, it's kind of mean to make the score 108-0. You kind of put in second, third string, try not to hurt them anymore.
Kick so much butt.
Can only kick someone's butt so
Kicking right
much.
so much butt.
I did.
In the first three.
So and that is a thing in football. That is a true thing. Like we talked about. I'm a Bama fan. This past weekend, we were beating them, and of course we put in our second string quarterback. And if we had beat them as well as I had hoped we had beat them, we should have put in the third string quarterback. You would use your other people, so it's not too much of a skewed score. But there's another reason as to why there are no outliers, and it's kind of an obvious one in life. It's different about basketball than some other sports, because some other sports allow this.
Is it harder to score? I don't know. Is it not?
It's
I
like
don't know.
seven.
I was just thinking that there's no ties. I know that sounds stupid, but if we allowed ties, then you would have won, even though
Lost.
you didn't win. So we don't allow ties. You have to go into overtime, like triple, like you can go into 7 overtime. Many overtimes to state, we're not going to tie this game. So it would be smart, again, if when you're doing this acronym, not only that you reference the context, but when you say no outliers, if you try to predict why were there no outliers? So if you use any of these reasons we gave to reference back to what the context of the problem was as to why there are no outliers in this specific set of data. Now there could be, miracles happen. There could be an outlier, but there's not. Okay, F is for form. Is R is linear or nonlinear? So
Most likely.
I like that. So I'm going to put the data follows a linear pattern. But should I reference the context if I hadn't already done so in the D and the O? Heck yes. It's never a bad idea to reference the context. And then the S is not for spread, because we're so used to S being for shape and spread. S for, when we're talking about a scatter plot, is for strength. So it looks like it's pretty good.
Moderate strength to the trend line.
So I would say moderate strength. I like that, moderate strength
Line of best fit, how it's called. Something like that.
to the,
Trend.
I like line of best fit. Trend line would work.
So long.
But I'm going to put a question mark over here because back to that's something we've not actually talked about today. Clearly that's what we're getting to because you see it's on the cute little handout that we just cut out. But we haven't actually talked about fitting a line to our data. We hypothesized that we could, but we haven't actually done it. Yes, dear. This book right here. Okay, so go back to your cute little handout. And we're going to go to the top left one. No. We're going to go to the top left one. Then it says, example to demonstrate linear regression in a TI-84 calculator. So sorry, Batman. It's not for you.
Okay.
Okay, so they had all this data. And they typed it in. You have to identify, we don't say the words independent and dependent though. What words are we using?
Explanatory and reaction.
Response. Okay, which one was which?
Explanatory was the points for something. Explanatory was the X. Response was the Y.
Is that correct?
Yes.
Can someone check? Why don't we look back and check?
Yes.
It says it on the thing.
I'm asking.
It's cognitive testing.
Yes.
Nope. Okay, so they asked us to identify the explanatory and the response variables and determine how to represent them. For us, with this specific problem, so if we look at, to begin with, they were talking about, okay, so here is tuition and fees on average for a year for a public college, which is ridiculous because Miss Compton started college in 08. So I was at 7,000. And as of, the data doesn't go past 2013, 2014. As of then, they were almost up to 9,000. So I imagine for now, for you, they're already at 10,000. I imagine. Which means $10,000 for just one semester at least. And this is an average four-year school. If you're thinking of Ivy League or anything higher, it's going to add a lot more money. Okay, so we want to type all this data in. So let's go to our stat plot, second stat plot. We're going to turn our one off from yesterday. I'm not going to delete it because we might come back to it. I'm just going to turn it off. And then second stat plot, I'm going to go to the second one. I'm going to turn it on. I just don't want to delete the one we were doing yesterday yet. And back to the fact is we can store lots of things on here. It's not dumb. However, we've got to go type in different lists because L1 and L2 are dealing with the points in the football game. So I'm going to go to Stat, Edit, and I'm going to type in L3 and L4 to deal with our money and tuition issue. Okay, so 03, 04, 04, 05, 05, 06. We can't type that in our calculator, can we?
No.
We're not going to type in 2003, 2004, because that just seems silly. So instead, and they've even explained it for you, instead we're just going to give them each a label. As in, that first year is year 0, second year, year 1, third year, year 2. So I'm just going to type in the numbers 0 through 10. 0. And L3. Because I'm not going to delete my data today because I don't feel like it. Plus, we can be brave. I mean, there's lots of L's. We don't always have to use all 1 and 2. So in L3, I've typed in 0 through 10. But when Kenzie goes back and has to explain, when she can't actually say 0, she needs to, somewhere on her paper, give a key that explains 0 means 2003, 2004. That's one mistake she could possibly make with this, but she'll be okay for now. Okay, and then in L4, I can actually type in those numbers of the monetary values. So 5,900, 6322, 6566, 6662, 6943, 7008, 7627. I did that wrong. 7672, 8174, 8557. Yes, dear. Uh-huh. Okay. So, and then again, I know I've typed it all in right. Well, I might have mistyped the number because we're all not perfect. But again, 10 and that are on the same level. So I know I don't think I messed up at least. Okay, so instead of actually typing in the years, we just did 0 through 10. And then for the monetary values, we actually typed in those costs. Is there anyone confused on this step? Okay, well then I'm going to go back to stat plot. We were typing in that second list in stat plot, so I'm going back to that second list. But instead of using L1 and L2, I need to do L3 and L4. If you hadn't noticed already, because I know at least one person hadn't. Lord Jesus, help me talk today. It's like I need y'all to be here first thing in the morning when the words come. Okay, if you press second and then 3, you'll be at L3. It's written in blue. And then second 4, and you'll have L4. And that way, I don't know how you were doing it before, but that makes your life so much easier. Now, part of me wants to immediately press graph, but you and I both know other people play on my calculator, so I should probably make sure it's zoom. Oh, maybe I'll press graph, second quit. Are you still in there the way I wanted? Yes, you are. So I'm going to zoom and make sure I'm zoomed stat plot first. And, oh my goodness, our data looks weird. Does yours look like this?
Yeah, looks
Like a bird wings. So if we were to use our new little acronym, UFS at this, for the direction, what would we say?
It does, you're right.
It does.
Positive association. So we would say positive association for the D. For the O, do we think there are any obvious outliers at the moment? No, but it would help if we fit a line through this data before we start calling outliers anyway. So that one's a question mark. What about the F? The form?
Looks pretty linear to me.
Is this linear? And that's the question. Is this linear?
Looks pretty.
I mean, it looks kind of linear, but at the same time, kind of looks like a bird. So, you know.
I mean, if you were to draw the line, it doesn't thing. It would
If you were to draw a line through it, would many of the points be close to that line? Yes. And then what about S for strength?
It's pretty strong. Looks pretty strong.
I mean, it seems pretty strong. So, again, his moderate word sounds good. So, moderately strong or moderate strength sounds good to me.
Which strength relates to what? So
How well is our points fitting the line, this imaginary line that you and I are about to draw? But we already draw it in our head. You already draw it in your head. You're like, if there was a line here, how good did they fit that line? Pretty good. Again, there's nobody, if this is, I'm going to make you mad again, if this is our fake line, no one's down here or way up here. So we'd say, yeah, pretty good. It's not bad. Looking good. Yes, dear.
On the book, it said like from left bottom to upright. Which one is it explaining form or explaining the
Left bottom to upright. That's the positive association and the negative association, I'm assuming. I don't know. You'd have to show me where.
if you didn't find it in the book, it's probably a
Okay, so you'd have to show me where. I don't know. I don't have that thing memorized yet. Okay, so we typed in all our stuff. It's looking good. We graphed it. We already knew how to do the stat plot part anyway. So we've got this wing looking thing. Look, now ours looks like theirs. Bird wings. Yay. Then we go to the next little flap. And it says, and this is a step that we didn't know to do before. So this is where Louise and all the others who were trying to do the backside of the age guessing activity were stuck. Because you didn't know any of this. Okay, so to get this line of best fit, because that's what we would like to calculate and put a nice little line on it, we need to turn our calculator diagnostics on. So you have to go to, and it tells you how, second catalog diagnostics on. So, second catalog. Second catalog. So, which one's catalog? I don't know either. So, I'm going to go to...
Oh, 0.
Second catalog is down at 0. God bless you. I knew my brain went dumb for a second. Second 0. Bless you, Alex. Okay, and then to get to D quickly, you can type alpha and then D. Or you can just scroll down. It really doesn't matter. We eventually actually do that in here. Okay, so look, they have a box plot thing. They have lots of other things that we've heard of before. So if we scroll down far enough, or again, if you cheated and went straight to D, if you want to go straight to D, you will press alpha and then the letter of the alphabet you want. Alpha and then the letters are in green. So alpha A would skip me to A, alpha D skips me to D.
So the catalog went to where?
I pressed alpha and then D, and now I'm scrolling down to diagnostics. Okay, and we're going to turn diagnostics on, and if your calculator is your calculator from here on out, that shouldn't have to be a step, but if you're using one of my calculators, which are used by the Mini, then this might need to be a thing you need to check. Diagnostics on.
Is that going to affect other
Done.
classes?
It should not, but if so, second catalog diagnostics off. It should not.
It's not,
Like,
Not that I know of.
simple math
Wouldn't
stuff.
think so.
where did you get this?
Second catalog. Then I went to the letter D. You can either scroll down or press alpha and then D to skip to D. If you press alpha and then D, it skips you to the letter D. And then I scroll down to DIG, diagnostics, on, and I pressed enter.
You don't want to do that.
Oh. Okay, so you got it?
Yeah, no.
Okay, so your diagnostics are on, and now we can actually find this line and put this line on there. So if we go to stat, our favorite button, we're on step 5 in your cute little handout. We go to stat, and then we go over to calculate. We actually see something that looks like mx plus b. So we know, hey, that's going to fit the line. And they use ax plus b, which is fine. You and I are so used to mx plus b, we get thrown off. But we're going to go to number 4. And then you and I did not type this in L1 and L2, did we? we typed this in L3 and L4, so we need to change the X list to second L3, and the Y list we need to change to second L4. Okay, and then here's the part that you and I want to skip, but we can't. So it says, if you look on your cute little handout, it says go down to, and this is the part I would probably underline, go down to store reg equation and select, and they tell you what to select. That way, so what we're doing, so let me scroll on my calculator. So you change the list, and then you were going to press enter because you and I are in a hurry to press enter. But instead here, we need to type something in here, that way it will actually store it for us to reference back. Otherwise, they draw a line, we don't actually know how to reference it. So if you press select variables, vars, y vars, function, and then y1, you should be able to press calculate, and it tells you all the things. So let me do that again. I'm just using your cute little handout. I'm just following the steps on it. So I press vars, I scroll over to y vars, y variables, then I press function, and then I tell it to store it in y1. But you know, later on you might want to tell it to store it in y2 or whatever. So it stored it, but I didn't have it on the thingy. Back to that. So stat, calculate, linear regression. I go down to this thing, I press vars, y vars, function, y1, and then if I press enter and calculate, it gives me all the things. So they tell you the A, they tell you the B, they tell you R squared, which I swear is super important, they tell you R, which is also super duper important. So you're like, thank you for giving me all the important things at once, my calculator. Thank you. So while that was a pain in the butt to get to this, super helpful now. Okay, so we got the same numbers as them. Hot dog, look at us. And this is the line of best fit. And our line of best fit is a very good fit because the correlation coefficient R is very close to 1. So if we look at it, we got 0.98. That's really freaking good. Anything 0.9 above is really stinking good. That means our line and our data are really similar to each other. Okay, so if we want to graph it, to graph it, step 6 says graph the linear equation from your y1 by selecting graph. So literally I press graph, and this line fits my data. Now I'm pretty sure that Alex could have figured out how to make the line graph his data to begin with, but I'm not pretty positive that he would have gotten all the information that you and I got from the screen before. Because that's where all the gold is. That's all the stuff we need to know in life. Okay. And that's where we're going to stop for then. We've not wanted to make a residual plot yet. But does anyone, just to be smart, does anyone have any idea what a residual plot would be showing us?
The difference from each individual point in the normal line.
Yes. So yeah, that's all it's going to be doing. So we're going to skip step 7 for now because I see the deer in the headlights look. But all it's going to do is show us how far away is that point really from that line. And how far away is each of these points. But instead of using the line in this graph, now the x-axis is what we're measuring how far away these points are from. Yay! Oh, goodness. Okay, we did all the things. We can put the little cute handout away unless there's a question about it. Okay, put the little cute handout away. Let's go back to our notes, and we'll just talk about the things that our cute little calculator gave us. Okay, in fact, if you want to leave it out, I know I just told you to put it up. I need to make up my mind. If you want to leave it out so we can reference that cute little table as to why it's so important, that'd be smart. Okay, so we just spent all this time figuring out how to get this cute little table from our calculator. I pray you at least read the steps again and know how to get this cute little table from your calculator. Okay, so if we get the cute little table, what we actually have is a correlation. And that's what this next section is about. Correlation measures the direction and strength of the linear relationship between two quantitative variables. Correlation is a unitless measure. It's between -1 and 1. If it's closer to -1, it's got a negative association, so it should have been a negative line. If it's closer to +1, it was a positive association. So back to when you did DOFS, and you were claiming that it was either positive or negative, you better check that R first. Because what's going to make Mackenzie look really stupid is if she says stuff has a negative association and then her R value is not a negative number. Okay, and then say it. Yes.
How did you make that mistake though? The slope is positive or negative?
I'm telling you, you'd be surprised at what people can do.
I mean, up, down.
I always say leans left is negative, leans right is positive. And if you bring me your paper and it's leaning left and it was supposed to lean right, I tell you that. But anyway, moving on. So if we get our R, and our R from our cute little table was 0.985. It's a really good R. And in fact, a second ago I said anything above 0.9 is great. That's a lie. Heck, anything above 0.8 is freaking awesome. We say there's a strong relationship between the two variables, the explanatory and the response. So if your R, after you calculate it, you get that cute little box on your screen. If your R is 0.8 or above, you get to use the word strong. If your R is between 0.5 and 0.8, you get to use the word moderate. And if your R is less than 0.5, you get to use the word weak. And you would say, Miss Compton, what about the negative values? But it's already accounting for those two because they're absolute values. So if it's between, if it's negative 0.98, it's a good one. If it's between negative 0.5 and 0.8, it's an okay one, it's moderate. And if it's less than negative 0.5, it's weak. Okay, and seriously, those are the key phrases they're looking for. So if you put the word strong, moderate, or weak, your R better fall into the corresponding range of values. In fact, they write you a cute little sentence explaining that. So if you say strong, positive, then you better say linear, and then you better even explain what the explanatory and the response variable is as well. Okay, so if we were to back up and practice this one last time, because I feel like I said a lot of things and a lot of people are in a different world, so that's why I did this. We haven't messed with our L1 or L2, so let's turn off, let's clear out that Y1. I just don't want it on my graph anymore. I'm going to get rid of it. Let's go back to our stat plot. Let's turn plot 2 off. Let's turn plot 1 on. Let's go back to our graph that we had from yesterday or from earlier with the points per game and the number of wins. I'll give you a second. Okay, so you and I, is that thunder? So you and I were making a lot of assumptions about that it was a strong, moderate, whatever fit. Why don't we actually calculate the things? So let's go to, it said go to, what were our cute little steps? Let's reference them if we need them up. It said go to stat, calculate linear regression. We don't want L3, we want L1. We don't want L4, we want L2. Is there anyone out here with me? You press stat, and then calculate, and then linear regression.
This is going to sound stupid. I got lost on the part. Where do you go to do turn the plot?
Oh, second stat plot, and then we turn plot 2 off, plot 2 on.
So you go to stat, and you hit
Stat, and then calculate, and then we see the one that looks like a line, so number 4.
I was trying to do that 1, 2, 3.
And then you and I are really excited, so we changed it to L1, we changed it to L2, we want to press enter, and that's great, but we really want it to store the regular. So if we don't press it, and we just calculate, it'll tell you all this stuff, but it won't be stored forever. And I mean, you're pretty smart, you might not need it stored forever anyway, but it's kind of nice to be able to reference again. I don't know, that's up to you. So, and then it doesn't actually graph it for us either. So if Louise is in a hurry, he does stat, calculate the 1 var and the 4. He does this and he doesn't store right here. It's going to tell him all the stuff he needs, but it's not going to draw the line to his data. and it's not going to store this cute little screen forever. So I like to store it, but he's smart enough that he just sees 0.93 and he's happy. In fact, he wants to change his phrasing. So, okay, so instead, if we did stat calculate for store regular equation, we were supposed to press variables and y variables and function, and we stored it as y1. My God, so many buttons today. Calculate. I see all this stuff, and I want to go back to my original phrases and change things. So you and I had tried the DOFS blindly, and now we probably need to change some things. So now that we actually have this cute little table, is there anything we should change in our original response?
Yes.
What?
Moderate and strong.
We need to change moderate to strong. Why?
Because it is above 0.8.
Wrong string.
I'm going to say strong strength of the data, of the data. Hunter's being picky about the words today. Strong strength of the data to the line of best fit, and then I probably want to throw in why I know it's strong, because of that R value. Okay, and then I think that's all we need to change with that, but if I go to graph, now that I'm looking at it, are we sure nothing's an outlier?
Yes.
Maybe that one near the bottom, but it's above the thing.
Yeah, that one looks fishy, but they all look kind of fishy, and that's why I know I've said too many things today, and I've already got you zoned out, and I know I have you for like 10 more minutes, but you're like, my God, Miss Compton, if you say one more thing, I'll just cry. If we were to do that residual plot, that would help us see it better. So that's why there's that last step to help us with the O with the outliers. In my mind, that's why. Okay, is anyone about to die? That was a lot of things. Okay, then I'm going to stop talking about the things, and I'm just going to let you be free. Would it be smart to work on stuff? Yes, it would. Is it going to be okay if you just sit there quietly and try not to cry? Yeah, that's fine, too. Plus, I don't really want to show you this formula and scare the bejesus out of you today. The good news is you don't have to know it. Oh, but your calculator just did that for you, did it not? So you don't have to know how to do that. Your calculator did it for you. As you can see, like I said, formula is very painful. No one actually does it by hand.
We should probably know how to do it though. You should know the meaning.
We are.